Gas chromatography is based on interactions between the solute and the solvent, which is our mobile phase, and the solid, which is our stationary phase. In this case, the mobile phase is going to be a gas, a carrier gas. The volatile liquid is injected into the column with a tiny microliter syringe. And we typically inject very small amounts, 1 microliter to 10 microliters. That sample is heated and quickly vaporized at that injection port. That vaporized sample is then transported by a carrier gas, which is our mobile phase. It's carried into a column where separation occurs. So it looks something like this. This is what our setup looks like. We have our carrier gases over here. All right, those gases are connected to a GC. At the top of the GC, we have our injection port. So that's where your little micro syringe would go in. You inject your sample there. And then inside of this is a large oven. This is a picture of the column. Now the columns that are in here can be anywhere between 10 meters up to 60 meters long. And as your compounds separate, they leave and enter a detector, which then the signal goes to a computer software program that shows you your peaks. Principles of separation are very similar to what we saw before with column chromatography and with thin layer chromatography. Here we have, though, a mixture of two components. This little black dots here, these are less volatile components, and the white ones are more volatile. They're injected into the GC, and they go through the column with the carrier gas. The gas is moving through this, and they enter the oven where the column is. It's hot in there. So they've been vaporized already at the injection port, and as they travel in, the compounds here that are less volatile are going to hang on to that liquid coating support on our column. So the more volatile components kind of come off a little bit faster, and they move through and they reach our detector first. Now that detector again records a signal, and that signal is handled with software on a computer to show us a peak. Now there are some other principles that affect separation here. That's the time that the different compounds spend in the vapor phase. That's directly related to their vapor pressure, right? So again, the more volatile, right, the lower boiling point, higher vapor pressure compounds, they arrive at the end of the column first and pass into the detector. The other thing that affects separation is the flow rate and the type of stationary phase, and also the length of the column. So the longer the column, the more theoretical plates our column will have. So columns that are 60 meters can have 100,000 theoretical plates. So you can get a nice level of separation in a column that's really long like that.